Student, today our lesson is electromagnetic radiation. Before we are going to study about electromagnetic radiation, let's take a discussion about waves. A water wave is some kind of familiar for you. When a stone drop into a water surface, you can see that kind of appearance. What you can see in this animation, we call a water wave. The speed of the stone when it drop into water will reduce. That means there's a loss of some kinetic energy. So this kinetic energy can transmit as water waves. That is the theory behind this kind of water waves. So when you can study about this kind of 2D animation, the cross section of a water wave, you can see this orange color particle. This orange color particle is moving in a circular orbit motion. So that means this is not moving when a water wave moving in left side to right side. The particles are only moving in a particular area, that is not moving from left hand side to right hand side. So then what is that moving part? But you can see, as usually you can see something is moving from left hand side to right hand side, but the particles are not moving that side. So what you can see, that movement, that is called energy. So this energy is moving from left hand side to right hand side in this water wave, but there's no any particles are moving. That particles are only up and down or this kind of circular motion. So then let's study about some terms in this kind of wave. Let's take the time which will take to complete a single circular motion of this orange color particle is t. So that means t is the time which take to complete one circular motion. So then this wave has a frequency. This frequency is equal to 1 over t. That 1 divided by t is called frequency. And let's take this kind of distance. Let's think that is the length is L. So then this L length is the length which pass this wave at time t. So then the velocity of this wave is called L divided by t. That is normal velocity is distance divided by time. So then these waves are moving from left hand side to right hand side. The velocity of this movement is we call L over t. So then this waves has a frequency and it has a velocity. So that is the very important terms in a wave. I stop in a position of this water wave and has drawn in this kind of diagram. So this has a frequency, velocity we already know, and there's a wavelength. Wavelength is the distance between two similar position or two nodes. Then there's an amplitude, that is the distance between the central point of this wave to the highest or lowest point. So therefore this is the special terms we should know in a wave. There's a relationship between frequency, velocity and the wavelength. V is equal F lambda. This is the relationship of this kind of wave. So radiation is also some kind of a wave. So these radiations, now let's study about these electromagnetic radiations. As you can see in this animation, this is we call electromagnetic radiation. This is some kind of difficult to understand because we can't see this kind of radiation in your eyes or in your any sense of human, because these frequencies are and these movements are not appear to human, therefore some kind of difficult to understand. But think about that is also a wave, it's like a water wave, but in water wave what will happen there, there's a moving water molecules and transfer energy into one direction to other direction. In electromagnetic waves, that is also movement. What is that movement is electric field and magnetic field. In water wave, there's a water molecules are moving part, but here the electric field increase and decrease, that is one direction, and to perpendicular to that electric field change, there's a magnetic field change also observe. So therefore this kind of electric field and magnetic field perpendicular to each other, the changing will affect to movement of the energy from one direction to other direction. So that kind of energy transferring part we call electromagnetic radiations. So these electromagnetic radiations also have similar wave properties. This also have frequency and velocity, and there's a relationship between frequency, velocity and the wavelength also. Here the frequency in electromagnetic radiations we are normally represented by nu, and the velocity we are representing by c, because that c is represent the velocity of light. Light is also an electromagnetic radiation that has a velocity of 3 into the 10 to the power 8 meter per second. That is the speed of light. That is not only the speed of light, that is the speed of every electromagnetic radiation. And therefore we can write down the relationship between the velocity of light and is equal to nu. Nu means the frequency of this electromagnetic radiation, and the lambda. Lambda is the wavelength of this electromagnetic radiation. Further study about electromagnetic radiations, let's go to our childhood. I think you all have done this experiment. White light beam passing through a prism, and you can see this changing their path due to different colors. For red color, less deviation, and the violet color deviate more. And finally, you can observe this kind of spectrum we call rainbow colors. You can see this rainbow colors using this experiment. This white light is also electromagnetic radiation. This has different frequencies, that is why it deviate different angles. For example, red color is the lowest frequency part of this electromagnetic radiation, and the violet color is the highest frequency. This part of this electromagnetic radiations we call visible light. Visible light is electromagnetic radiation which can detect to human eyes. That human naked eyes can detect only this electromagnetic radiations. We call that part as visible light. And how about this kind of sunlight passing through some water droplets in the sky? You can see a rainbow in the sky. That is also the movement of different angle their light when passing through a water droplet into different angle. That is why you can see this rainbow. Another thing, I will take one example of dogs and cat. Have you heard about the dogs and cats have color blind? I think you all have heard about that one. This is general knowledge. That means they have color blind. What is this color blind means for dogs and cat? Okay, I will project. They can appear this kind of rainbow. How I can project this one? Because their eyes, not like human eyes, that eyes can detect only low frequency part of this electromagnetic radiation, and the high frequency part they cannot detect. That is why I cut off that high frequency part of this rainbow and the low frequency part, and I go more, because we can't see that part of this rainbow, because we cannot see electromagnetic radiation which has the lower frequency than red color, but they exist in the nature that can detect to dogs, and dogs can have different colors than human. They can have bow color, bow color or something. They are talking about this kind of different colors. Cat also have different colors than human. They can have some kind of meow color. So therefore they can see more colors than human. So then human cannot see in the dark night time, because at the night time there's no visible light appear. But do you know the human and some plants and animals can emit infrared? What is that infrared? Let's take this electromagnetic radiation above red color or below violet color. The above red color we call infrared. That means the radiation, electromagnetic radiation, which has the frequency less than red color, we call infrared. And the electromagnetic radiation which has higher frequency than violet color, we call ultraviolet. So that is why these dogs and cats can see infrared. That means the frequency which has lower than red color, electromagnetic radiations they can see. So that is why the human and other plants can emit this kind of infrared part of electromagnetic radiation. So that is why they can identify using their eyes. Okay, let's study more about this kind of electromagnetic radiation. Okay, let's divide this electromagnetic radiation. These are continuous spectrum, and I divide into discrete spectrum. And this part is visible light, and I take into right hand side high frequency part and left hand side low frequency, or we call high wavelength part. Here I divide this spectrum, total spectrum of electromagnetic radiation, into different categories. For example, just near to the visible light, the frequency lower than red color, we call infrared. And next to infrared, there's a radiation we call microwave. And very low frequency part, or we can say high wavelength part, we categorize as radio waves. Therefore, because actually we categorize these into three parts below red color visible light, into three parts because their nature. Some radio waves can have different nature than microwave, and their energy is high, and their interact with molecules are different. And next part is infrared. They have high energy than microwaves, and they are also interact as different nature with the metals. Therefore, we divide into three categories. And higher than violet, we have ultraviolet part, and above that frequency we call X-ray and gamma ray. That is also some part of electromagnetic radiation. So those are the electromagnetic radiation categorized into different parts. And very high frequency we call gamma ray, and very low frequency we call radio waves. And the margin part you should know when you are study about electromagnetic radiation. For example, I will take the wavelength is 700 nanometer and frequency is 400 terahertz. That kind of part we call red color, but below that frequency we call infrared, and higher than the wavelength 700 nanometer we call infrared. And next part, lambda is 390 nanometer and frequency is 789 terahertz, we call violet. Above that frequency we call ultraviolet, and that lambda they have lower than 390 nanometers, we call ultraviolet. And other series also have that kind of lambda and frequency in their marginal part. So therefore you should know, it is better to study what are the frequency limit for radio waves, microwaves, infrared, visible light, ultraviolet, X-ray and gamma rays. So if you know that part, it is easy to understand what is the radiation by knowing your frequency and wavelength. Therefore, please study these values and study more for your further knowledge. Now let's study the relationship between this lambda and the frequency and the energy. Before that, we should know about photon. What is this photon? It's a particle representing a quantum of light or other electromagnetic radiation. A photon carries energy proportional to the radiation frequency but has zero rest mass. That means it's a kind of particle, the smallest particle in electromagnetic radiation. But it's not an actual particle because that has no mass. That is the smallest energy unit. We can say that is the smallest energy unit in electromagnetic radiation. We call a photon. The energy of a photon of a radiation is proportional to frequency and lambda. And this is the equation of energy relationship between the frequency. And this H is equal to Planck's constant, that is 6.62 into 10 to the power minus 34 joule second. That is the value for Planck constant, and this energy is equal to H by frequency. That is most important equation for you. That is very important because any radiation, that energy of single photon is equal to H over nu. Nu means the frequency, H means the Planck constant. Study more about this equation, and also we should know the electromagnetic radiation interaction with matters. What is these lines I have drawn in this slide? That is what we have done in our previous studies about energy levels in an atom. Okay, let's think about there's a energy levels in atom. I give a number for this energy levels. N is 1, N is 2, N is 3, N4, and go to infinite number of energy levels in a single atom, which an electron can exist, as we study in Bohr theory. So this electron can exist in any of this energy level, but it cannot exist in between these two energy levels. It can exist only in this energy level. So the y-axis, the above part, represent the increment of the energy. So you can observe when absorbing electromagnetic radiation, it can go to high energy levels, and when it come to low energy levels, it can emit some radiation. It can go up and go down by emitting radiation, and it can go up by absorbing electromagnetic radiations, go down with emitting electromagnetic radiation. That is the things which happen in an electron in an atom. So this emission and the absorbance of electromagnetic radiation will effect to change this energy in atoms also. So this energy between two energy levels we call this E. So this E is equal to h over nu. That nu is the frequency which emit or absorb by this electron. This emit by releasing energy and absorb by absorbing energy. It can go to high energy levels. So this difference between these two energy levels is E is equal to h over nu. Nu is the absorb or emitted radiation, the frequency of that absorb or emitted radiations. So that is very important to understand in the further study about the electromagnetic radiation interact with matters. Now let's take a sample which has number of atoms exist. That means there are number of electrons are moving around this nuclei, and it can absorb or it can emit radiation. So let's take one sample which exists that kind of atoms. For example, let's think about this is hydrogen atoms. There are number of hydrogen atoms exist in one sample. Let's take this experimental setup. Here there's an electromagnetic radiation source and hydrogen gas sample. When it passes through this hydrogen gas sample and take into a prism, and when it move through a prism, you can observe a light spectrum as similar to the previous experiment. However, there are some dark lines appear in this spectrum because of this hydrogen gas, because that passing through hydrogen gas, and it can absorb some part of this electromagnetic radiation. Let's see in the zoom view of this spectrum. This dark color lines is due to the absorbance of that electromagnetic radiation by hydrogen atoms. So that electromagnetic radiations are missing. So therefore we call this spectrum as absorption spectrum. This is the absorption spectrum of hydrogen because it passing through hydrogen atoms. And let's take discuss about the emission spectrum of hydrogen. Here the similar experimental setup, but we remove that the electromagnetic radiation source, and we are giving an electric spark to this gas sample. This gas sample can absorb this electric spark energy, and then they will emit some kind of radiation, because that high energy electrons can move to the down energy levels by releasing by emitting electromagnetic radiations. So that electromagnetic radiation can see when it passing through a prism, and the spectrum you can observe some colors in the screen, because which can emit by the hydrogen gases. Let's see the zoom view of this spectrum. That is the spectrum of hydrogen by due to the emission of electromagnetic radiation by electrons coming from higher energy levels to lower energy levels. We call this spectrum as emission spectrum. About Rigberg formula, that is also is used in atomic physics to describe the wavelength of spectral lines of many chemical elements, what you have seen in the hydrogen spectrum also. And it was formulated by the Swedish physicist Johannes Rigberg and presented on 5th November 1888. This is the formula of Rigberg formula what he has proposed. Here let's study what are those terms. In here, this Rigberg formula, this lambda represented by wavelength, and Rigberg constant is R, and Z is the atomic number, and N1 and N2 are integers which go to 1 to infinite value. And this corresponding to principal energy levels of the orbital occupied before and after. Let's study about principal energy levels and those kind of thing in future lessons, but up to now you should know this N1 and N2 are the numbers representing the energy levels what we have done in our previous slide also. And for hydrogen, this RH or Rigberg constant is equal to 1.097 into the 10 to the power 7 per meter. That is the value. So we can use in different value for different units. And Z, that means atomic number of hydrogen is 1. So when you are going to apply this Rigberg formula to hydrogen spectrum, you can use this value for that. Here I will take some different energy levels. N is 1, N is equal to 2, 3, 4, 5, 6, 7, and we can go to infinite value. So this energy levels represent by N. So then what is this N1 and N2 represent? Let's take one electron comes from second energy level to first energy level. So then N1 is 1 and N2 is 2, because this electron come from N is equal to 1. So therefore N1 is 1 and N2 is 2. So let's think about another movement from third energy level to first energy level. Now the N1 is same, because the lower energy level is 1 and N2 is 3. Therefore when you are going to apply the radiation emit from this movement of electron, you can calculate using this Rigberg formula. 1 over lambda you can calculate. R is well known part. Now Rigberg constant and Z is 1 for hydrogen, and N1 is 1 and N2 is 3. So therefore by moving of this kind of electron from third energy level to first energy level, there may have some emission of some electromagnetic radiation. That radiation contains that lambda value or wavelength equal to using this Rigberg formula we can calculate. And further study, you can calculate different kind of wavelengths for different kind of energy transfer and moving of different electrons to different energy levels. So think about one electron contains the highest energy level, that means infinite energy level to first energy level. You can use infinity value for N2. So 1 over infinity means 0. So then that part you can calculate. So therefore this Rigberg formula is very important to calculate the wavelength of radiation when an electron moves from different energy levels. Let's go to next kind of movement. Think about this kind of movement of electrons to second energy level. So that kind of movement N1 is 2, because every movement at the end they stop at the second energy level, and you can take different N2 values. And similarly, when any electrons move to third energy level, that emitted radiation you can calculate, and then you can use N1 as 3 because that electron move to third energy level. So therefore any movement of electrons from higher energy levels to lower energy level that can emit radiation, that emitted radiation wavelength you can calculate using this Rigberg formula. And one part of this kind of radiations we can divide into three category in this movement of this, in this image: Lyman, Balmer and Paschen, and there are large number of series you can divide, and this can study more in the assignment 1. If you have done this assignment 1, you can see a different kind of radiation appear when an electron move from higher energy level to lower energy levels. This Rigberg formula is used not only to calculate the emitted electromagnetic radiation in hydrogen atoms, but it can also use for different kind of other atoms also. In other gaseous atoms also can absorb different kind of radiations. However, that wavelength of emitted light depend on the element, and this Z value, that means atomic number, is changed in the different atoms. For example, helium, that is 2, and other atoms also has different Z values, and also that has some Rigberg constant also particular elements. Here in this image you can see first one hydrogen spectrum, the second one mercury spectrum, and the third one phonion spectrum. That is different due to the different energy level of that electrons exist. In this lesson, you have learned about electromagnetic radiations and their properties. You also learn about the different categories of total electromagnetic radiation spectrum, and you learn about the energy per photon of an electromagnetic radiation. Finally, you learn about the emission spectrum or the absorption spectrum of an atom due to the changing of their electronic energy level. And this is the end of this lesson. I recommend you to study further about electromagnetic radiation using different sources in books, online, or any other method. So thank you very much for your attention, and let's meet from the next lesson. Thank you.